Digital twin is a term you may or may not have come across. I'm actually joined by Tebis today, and Paul is going to be talking me through their version of what is essentially a digital twin. So Paul, virtual machines, talk us through it.
Yeah, thank you, Joe. Cheers. So this is a concept that Tebis has actually been doing for a very long time now in the way the software operates. So virtual machines, this is one of our library files. It's one of 5 important library files, being coding tools, the virtual machines, features, standardized machining cycles, and actually standardized processes. But the virtual machines obviously is a very important point of it, because we need to understand the technology that we're actually going to machine the part with. Okay. Now, first of all, we can see the library on the screen here, and you see the machines are set up into different groups. These could be small machines, large machines. They could even be, you got lathes, turn mills. It could also be machines that are going to be for roughing and finishing.
So how do you get around? Because you may have essentially 2 machines which may appear the same, but they're not, of course. Each machine is slightly different.
Yeah, so what we do is we have 2 concepts here. First of all, we have a catalogue machine. And the catalogue machine is something that we would produce with a post-processor. And this will give you an idea of the kind of kinematics that the machine will produce. But what we actually promote is to have a full measured machine. Okay. Now this is something that what Tebis will do is we'll come in and measure your machines. We'll look at the controller, and we'll take the macros off the controller and embed them into Tebis. Now why is this important? Because a lot of systems don't control the connections between the end of one toolpath to the start of another, which essentially is very dangerous because the controller takes over at this point, and we don't know where the collision is going to appear, if there's a collision going to appear in between. It could even be things like the tool changes. We can simulate the head changes all in one virtual machine. Okay, and you can see...
Again, working with your tooling library.
Absolutely. So all of this all links in, it all feeds in together. Okay, now and as you can see here, you can see the macros now have been flagged up on the machine, so we can see where the machine is going to move to in reality, and that's what you will get. Okay, so when we come in and do this, we take all of those macros, we embed them into the software, and the software then for the virtual machine and the post-processor talk to each other, they're linked, so we know that the simulation is good. But also what we do is we have a sign-off procedure, which is very important to the customer, because we actually prove parts out with them to make sure they're happy. We're actually saying, okay, this is a sign-off, this is a service we've done. Are you happy with the result of this? And we're going to give you, a signed piece of paper as well at the end of it.
So we're talking about planning, programming, verification.
Absolutely. So yeah, so the virtual machines are used in 3 stages of the process. Again, this is very important because, first of all, we have planning. If I have a component, I'll need to understand which machine this is going to fit on. Okay, so maybe in the timing plan, someone said, okay, you need to produce this part, it has to fit on this machine. The first thing I need to do as a programmer is the part going to fit on that machine in reality? What's my optimal setup position? What tool lengths, what tools am I going to use? And I can do all of this in the planning stage, okay, to actually figure out where the part's going to go. Because what we don't want to do is, if we know that we have some 5-sided machine or a 5-axis, a collision against the table or the machine head, fixturing. So all this is very important.
You mentioned fixturing. We talked about the machine tool, but how about the vice, clamps, things like this?
Yeah, all of this should be controlled as well with the machine libraries. So the libraries, we can pull in all of the clamping fixtures, and all of this is collision checked against in the machine itself. So when we actually then come to programming, okay, all of the kinematics that are stored within the machine are used in the programming stage. So we're not going to produce a toolpath which is not able to be created in reality. Again, coming back to this digital twin concept.
Yeah, kinematics is quite an important thing. Again, each machine is very slightly different. Absolutely,
yeah. Which is why it's important we come and measure up and we understand exactly what this machine is going to do. And when we come back to macros on this, it could even, the subject of macros, it could even be that as a user or a machinist, I've actually created some of my own user macros on the control. We can even import them into Tebis too to deal with this.
Okay, so are we saying it is a true digital twin? Whatever's happening on your desktop is what you'll get outside of the machine tool?
Absolutely. It's got to be, because people need process confidence. And also, if we're going to do automation, automation is what we promote, is you need to have confidence that that machine in the digital world is going to give you what you're going to get in reality. Yeah, it's very important for the customer, for the safety.
Okay, so finally, if I can ask you to conclude, people that may or may not be aware of digital twin, you know, why would they use digital twin, and in your case, Tebis?
Okay, so digital twins, what we're promoting is we want you to have safe, efficient processes. Is the main one, and as we've talked about, we can use the virtual machine in the planning and programming stage, not just for verification like most other systems. It's going to give you collision checking against all of your tool changes, even machine head changes. Asymmetrical heads will be considered. Where's the bulk of this machine head going to be in reality? You know, is it going to be where I expect it to be? You know, this can cause a collision. We're going to you're able to interactively control the machine within the verification. Multiple setups. Okay, this is a very important point because...
What do you mean, up 10, up 20 type thing?
Well, multiple setup could be, I want to maximize my machine capacity. Okay, I want to reduce outsourcing. Multiple setup is a great way of doing this. So maybe I have 3 or 4 programmers. Maybe I have one programmer who's machined 3 or 4 parts, all separately. All of these can be added into the virtual machine world. Okay, and all of the tool changes, the tilt directions will be optimized, and all collision checked against the same collision checked against each other for a maximum machine efficiency. As we talked about, the toolpath link is very important from the machine macros, and yeah, you're going to get full collision against the whole machine, all the clamping devices, everything that's on there, even other parts. And finally, because we've done all of this work on the verification side, all of the macros, we understand the machine controller. So you're going to get a very, very accurate machine and time estimate from it.
Okay, fascinating. Thank you, Paul. So if you're watching at home and you want more efficient cycle times, maybe more cost-efficient machining, get in touch with Tebis about their digital twin, which they call virtual machines.